Nearly every Arduino project you'll ever see starts here. This is the Arduino IDE, or Integrated Development Environment. It acts as a code editor, a compiler, an uploader, and a communication tool all in one. It lets you write code, upload it to your Arduino or other microcontroller, and then see the results in real time using the serial monitor. A new file in the IDE is called a sketch. There are several built-in examples, or you can create a completely empty sketch. Inside every sketch, there are two main functions, setup and loop. Setup runs once when the device first receives power and boots. Loop runs continuously afterward, repeating until the device is powered off. At the top of the IDE, you'll see buttons for verify, upload, and debug. Verifying checks that your code will compile correctly and is useful for catching syntax errors without needing a board connected. Uploading compiles the sketch and sends it to your device, causing it to restart and run your code. Debugging starts a full hardware debugging session, which can be helpful for deeper troubleshooting beyond simple serial messages. Now, next to these buttons is a device selection menu, which appears when your board is connected to a COM port. If you don't see your device, you may need to install drivers. And if the drivers are installed, but the IDE still can't see the board, antivirus software can sometimes block port discovery, so that's worth checking. Once connected, this menu lets you select the correct microcontroller. Some boards do require additional configuration files. These can be installed by going to Tools, Board, Boards Manager, and then installing the specific package for your board. This menu also allows you to configure board-specific settings. So let's open an example sketch. Go to File, Examples, Basics, and then Blink. This sketch turns an LED on and off every second as long as the board has power. It's a simple way to confirm that your board is connected correctly and that you can successfully upload code. In the setup function, which runs once the Arduino powers on, you'll see this line: pin mode, LED built-in, output. Okay. This tells the microcontroller that the pin connected to LED built-in, which is a predefined pin on most Arduino boards, should behave as an output. This means the Arduino controls the voltage on the pin instead of reading from it. The loop function runs continuously after setup finishes. Inside the loop, we use digital write to control the pin as a digital GPIO output, which means it can be set to one of two states, high or low. When we write high, the Arduino drives the pin to its supply voltage, allowing current to flow and turning the LED on. After a delay of 1,000 milliseconds, or 1 second, we write low, which pulls the pin down to ground, stopping the current flow and turning the LED off. And this repeats continuously, which is why the LED blinks. Now, let's say we want to turn the LED on when a button is pressed. If we connect a button to pin 2 and reference the board's pinout, we tell the Arduino in setup that this pin is an input using pin mode, button pin, input. In loop, we read the button state and use it to control the LED. Button state equals digital read, button pin. We'll add an if statement to determine whether or not the button is being pressed. If button state equals high, or is being pressed, digital write LED built-in high, turn the LED on. Else, or if the button is not being pressed, digital write LED built-in low, turn it off. This demonstrates how GPIO pins can be used as both inputs and outputs using high and low, but this is just scratching the surface. Not all pins are digital. Some pins support analog input, like reading a potentiometer, or an analog style output, such as dimming an LED. Analog inputs usually return a range of values, while analog outputs typically use pulse width modulation to represent values between 0 and 255. That might look like this. Sensor value equals analog read, analog in pin. This is for taking something that has an analog input, like a sensor, and reading from it. Output value equals map, sensor value, min value, max value, 0, 255. This allows you to map a sensor value between 0 and 1023 typically to 0 and 255. Finally, you have analog write, analog pin, output value. This is a simple writing of an analog value to a pin. Using analog values allows for finer control when devices need more than simple on or off behavior. Finally, the last two things I'll cover are libraries and the serial monitor. Libraries help you reuse written code by Arduino or other developers. For example, if you're using an ESP32 and want Wi-Fi functionality, you might include a library like this, #include wifi.h. The serial monitor is like a window into what the Arduino is doing while your program is running. It allows the board to send text and data back to your computer in real time, which is especially useful for debugging, checking values, and understanding how your code behaves. Instead of guessing what's happening inside the microcontroller, you can print messages, sensor readings, or state changes and see them instantly. There's a lot more to discover when using Arduinos or other microcontrollers in the Arduino IDE, but you can get by with some of the basics I've covered here today. If you're interested in learning more about microcontrollers, modules, coding for Arduino, or more, I highly recommend taking a look at the official Arduino website linked in the description. There are a lot of projects available online that other people have posted for you to be able to download, learn from, or utilize yourself. I hope you enjoyed this quick beginner lesson on the Arduino IDE. Please feel free to like, subscribe, or drop a comment if you have a question or you saw something you'd like me to clarify. This is Problematic. Thanks for watching, and have a good day.